walk us through a program and running it with the simulator. So I've already started the project and I've already typed in my program. As you can see, the program really doesn't do anything too exciting. The program starts at location 0. It loads register 16 with a 3. It increments it by 1, subtracts a 4, which will be a 0, subtracts another 1, which will be a -1, and then runs into a no-op, which is a no operation. Let's see if this builds correctly. So we say Alt-B and B for build, and as you can see, it builds fine. Then we will come over here and we're going to come up to debug, and this menu shows that we can step into the program with the simulator. And so let's do that. Let's click over here. We'll hit F11, and that's going to step into the very first line of the program. If I hit F11 again, you can see that the yellow area is the next line to be executed, which means we've executed the line before it, which means that R16 is a 3. And if you come over to the window on the right, you'll see that the R16 indeed is that 3. In this window on the right, we can also look at the flags, which is called the status register. We can look at the program counter, which is pointing to the number 1. And that means the next instruction that will be executed is at memory location 1, which is over here, shown by the arrow. The arrow is pointing to the increment R16. That's memory location number 1. And of course, the line before it is memory location 0. And the instruction after it is memory location number 2. So if we hit F11, we will increment R16, and the R16 will go to a 4. Let's see if that works. I'm going to hit F11, and the yellow arrow goes down to memory location 2, as shown by the program counter up here. And the R16 should be a 4, which it is. The next line to be executed is the subtraction. We haven't done that one yet, and when we do, the R16 will drop to a 0. So let's hit F11. And at this point, the R16 should be a 0, which it is. The program counter is pointing to the next location, which is location number 3, which is another subtraction. In this program, we can set the frequency at which the chip runs. The native speed of the AT-Tiny13 is at 1.2 megahertz. The simulator is set to 1 megahertz, so if you want to change this to 1.2, you can come up here and type in a 1.2, which accurately represents the native frequency of the chip. The stopwatch can be used. You can set this to a value like 0 or whatever value you want to, and you can use it to time the time it takes for these instructions to occur. Okay. Well, watch this next instruction when we execute it. We're going to do a subtraction of 1 on register R16. And notice that the R16 value is currently a 0. So when we subtract 1, we'll get a -1. Let's do that. So I hit the F11, and what did we get for the R16? Well, you notice it's not a -1 necessarily. It looks, in hex, it's an FF. But as you know from the prior chapter, the FF in hex as an 8-bit signed number is indeed -1. So that did work. Another way to look at it is we had a 0 and we subtracted 1. We roll all the bits over and we get all 1s, which is FF. You can, if you hit F11, the simulator will just wrap around to the beginning of the program again, which is fine. So now I'm back at the beginning of the program. Suppose you want to run your program all the way down to, say, here, towards the bottom. You can put a breakpoint in by clicking on the left side right there. Then, if you hit F5, you can run into that breakpoint. So I'm going to hit the F5 and I run to that breakpoint. So at this point, let's stop debugging, and that'll be the end of this video.